So in this video, I wanted to go through what RAM is, and we'll go through it quite in depth. Oh, sorry, see my hands doing the same thing again. RAM, what RAM is, what it means, and what it does, and where we use it effectively. So it actually refers to random access memory. Access memory. Sorry for the handwriting. And what this is meaning, we'll go through this in more in depth, but what this effectively means is that it's a I was going to say a random access of memory, but let me just get rid of that a second. But effectively, we're getting this CPU to do calculations, and as I've mentioned before, it needs to go over and talk to the RAM. Well, this RAM looks like this sort of thing on most computers. This is kind of looking down. No, it doesn't look anything like that. I'm sorry. But anyway, it's a stick, right? It's a RAM. I'll show you some RAM modules. There's some DIMMs in a second. But this RAM here might have a few sticks of RAM. It'll effectively be talking to the CPU about, let's say, I want to do 10 times 20 times 30 times 10 to make it easier. So what these will be doing is effectively securing it. So it'll be storing in here. There'll be an electric current that goes through here, and we'll talk about that in more in depth in a second. But the RAM will be like this back of the envelope stuff, as I was saying before, that it's like so 10 times 20. Okay, so 10 times 20 is 200. We'll just put that down there and store that for a second. We'll call that like a interim calculation number 1, and then we'll do the 30 times 10 section, and we call that the 300 section. That could be the interim calculation 2. Then we need to do another calculation together, put it together. So we've done this one and this one, and we've done this one and this one. Now we can multiply both of those together. So now we can do 200 times 300, and we can do a calc. Now this might not be called interim 1, but each one of these, you've got to realize that each one of these is in itself a piece of stored memory, right? Each number is a piece of stored memory. Even this symbol is technically a stored piece of memory. So that will need to be getting transferred over into the CPU, and it will be using it. So it'll go through these adders and multiplication things, and it will come out with some kind of answer at the end of it by doing all of this put together. So let's see what that is. That's 4 zeros, so that's going to be 1, 2, 3, 4, and a 2 times 3 is 6. So there you go, bang, and we now have our CPU output. So our CPU output is this. This might be a stored. This might be a stored number. Perhaps that's in fact, no, it's not interim anymore. That's the actual output number. So let's call that the final number. So F1, the final number. We're going to store this 60,000? Yeah, 60,000 as F1. Well, okay. Perhaps I need to use 60,000 as something else. Perhaps I take the 60,000 and turn it into I have to run 60,000 through the CPU again. So through some kind of circuit that can add, right? Circuit, something like that. Circuit that can add. But again, I'm taking a value. I'm taking something. This would probably be in software. Somewhere along the way, I've had to input some numbers in the first place. I've had to tell it a state. I've had to say 10 and 20s and 30s and 10s. So this whole software will be inside this RAM effectively. The way we go through it will be the stacks and the heaps and things like that. And we'll go through RAM in depth. It's partially one of the main security principles we definitely need to know quite in depth. But the software will be loaded up into it, and within the software you'll get variables like this. We'll get 60,000, and then within the software it'll get told to go and compute something. Now it needs to use the CPU to compute this thing, and as it does use the CPU to compute this thing, so this RAM will be going through it. It'll be talking to the CPU constantly. Sorry, you just go on here. It'll be constantly talking to this, and it'll be doing some calculation here. So it'll be a function, and we've got the standard input, we've got the function, and we've got the output, right? And our outputs and inputs will probably be stored more in RAM than anything. Then we may have a file, so we may be telling it to input this and do that, and we might have written a load of stuff down and stored it and put some values down and stored it in a document, in a text document, and then that whole file has saved. But all of those things, even saving the file, saving the this, doing that, writing things down, putting the inputs in, getting processed, it'll all be using the CPU to go and do things with. It'll be doing things in the CPU, which is this function machine sort of thing. And the storage of the interim variables and the things that it's doing and the passwords that it's got to pass across is all being done in RAM. Having said that, now this text file, this document.txt file that we've just created, now that needs to be stored in a hard drive, which is very different to RAM. This hard drive will be something very different, and it will look bigger, and we'll have a 4 terabyte version of a hard drive. So in the next video, I'd like to go through the difference between RAM and hard drives.